This video is about simplifying using the laws of exponents. So today we're going to look at quotients or division type problems. So to divide powers having the same base, we are going to subtract the exponents. So to determine wherever the base is going to end up is whichever has the largest exponent. So in this example, we have 3 to the ninth over 3 to the third. So since 9 is the larger exponent, it's going to end up in the numerator. And in our second example, x squared over x to the fifth, 5 is the larger number, so it's going to end up in the denominator this time. So let's look at some examples. Number one, we have g to the 19th over g to the 12th. So 19 is the larger exponent, so it's going to end up in our numerator, and we are going to subtract the exponents, 19 minus 12, so we get g to the 7th. In number 2, we have 5 to the 7a over 5 to the 13a. Since 13a is the larger exponent, this time we're going to end up in the denominator. So we're going to have 5 to the 13a minus 7a, and since there's nothing left in the numerator, we're just going to put a 1. So when we subtract, we get 1 over 5 to the 6a. Now, number 3 has two different variables. It has a d and it has an f. So we're going to treat each of those variables separate. So when we look at the d, the larger exponent 12 is in the denominator. So in the denominator, we're going to have 12 minus 9. And for f, the larger exponent's in the numerator, so we're going to subtract in the numerator 30 minus 5. So when we simplify that, we get f to the 25th over d to the third. In number 4, before we look at our exponents, we notice that we have a 10 and a 20 that are just numbers without exponents. So if they're just numbers without exponents, we can reduce them like we would a normal fraction. So each of those numbers is divisible by 10. So that would reduce to 1 over 2. Then when we look at the v, the larger exponent is in the numerator with 9k. So we have v to the 9k minus k, which remember is really a 1k. So 9k minus 1k gets us 8k. So we have v to the 8k over 2. We don't need to write the 1 anymore because there is something in the numerator and we're just multiplying that with 1. And anything times 1 is just itself. Number 5, we have two numbers. We have 8 and 12 without exponents. So we can reduce those by dividing both of those numbers by 4. So we get 2 over 3. Then when we look at our variables, we have m to the 15th is the larger exponent. So in the denominator, we're going to have 15 minus 9. And for q, 20 is the larger exponent because this q on the top only has an exponent of 1. So that's also going to end up in the denominator. So we have q to the 20 minus 1. So this simplifies then to 2 over 3m to the 6th q to the 19th. The other property that we're going to look at then is the power of a quotient. So when we have an exponent that's on the outside of the parentheses, we are going to multiply those exponents to both the numerator and the denominator. So if we look at the example on the right over here, the exponent was 8, so 7 had a 1, so 1 times 8 is 8. 2 times 8 gets us 16, so we have 7 to the 8th over m to the 16th. So let's look at a few examples. So in number 1, we have 3 to the 9th over 8 to the 3rd, all raised to the 3rd power. So we're going to multiply both of those exponents by 3, so we have 9 times 3 and 3 times 3. So when we simplify those, 9 times 3 is 27, so we have 3 to the 27th over 8 to the 9th. With number 2, we're going to multiply our exponents by 9p, so we have h to the 2 times 9p over g to the 4 times 9p. So when those multiply, we get h to the 8p and g to the 36th p. In number 3, we have parentheses 5v to the third over w to the ninth, all raised to the negative 10th power. So remember that this 5, if it doesn't have an exponent, it's an exponent of 1. It's not connected to that v. So all of these are going to multiply with the exponent of negative 10. So we have 5 to the 1 times negative 10, v to the 3 times negative 10, and w to the 9 times negative 10. So when we multiply, we have 5 to the negative 10th, v to the negative 30th, and w to the negative 90th. Now remember, we're not allowed to have negative exponents, so they need to switch from the numerator to the denominator. So 5 and v will move to the denominator, and w will move up to the numerator. So we now have w to the 90th over 5 to the 10th, v to the 30th. Now, if I was to evaluate 5 to the 10th, I would get larger than a 4-digit number, so I'm going to leave it in exponent form. So let's put it together and look at some examples. So in the first one, we're going to distribute our negative p exponent. So we have a to the 8 times negative p over a to the 40 times negative p. So that gets us 8 to the negative 8p and a to the negative 40p. Now notice that both of these exponents are negative, so they need to switch from the numerator to the denominator, and vice versa. So that gets us a to the 40p over a to the 8p. Because they have the same base of a, we can subtract those exponents. So looking for the larger exponent is 40p. So we're going to subtract and leave it in the numerator. So we have 40p minus 8p, which gets us a to the 32p. In number 2, we have some numbers that right off the bat we can reduce. So we have 7 and 49. Both of those numbers are divisible by 1. So I'm going to have 1 over 7. Then notice we have some negative exponents, so we need to move those. So c to the negative 10th needs to move to the denominator. C to the 45th needs to move to the numerator. And x to the negative 5th needs to move to the numerator. So when I rewrite this, I have x to the 20th, x to the 5th, and c to the 45th in the numerator. And in the denominator, I have c to the 10th. So we have exponents for x that are in the same part of the fraction, so those can be added together. So we would have x to the 20 plus 5. Meanwhile, we have c in different spots, so we're going to subtract those exponents, and we have c to the 45 minus 10. It ends up in the numerator because it is positive and a larger number there. And then remember that our 7 still goes in the denominator. So when we simplify this, we get x to the 25th, c to the 35th, all over 7. Number 4, before I can subtract my exponents, I notice that I have bases in the denominator that can be added together first. We also have the numbers 4 and 8, which can be reduced. So when we reduce those, we have 1a to the 8m over 2 a to the 14m, because I'm going to add those exponents together of 2 and 12. Now the larger exponent is in the denominator with the 14m, so I can go ahead and subtract my exponents. So in the numerator, I'm left with 1, and in the denominator, I have 2a to the 6m, because 14 minus 8 is 6m. Number 4, I have a to the 8r times the quotient of a to the 15r over a to the 9r. So first what I'm going to do is I'm going to get rid of this quotient by subtracting my exponents, and 15r is the larger exponent, so it's going to end up in the numerator. So 15r minus 9r gets us a to the 6r. I'm going to rewrite the a to the 8r. Now, because both of these are in the same part of our fraction, they're both in the numerator, we can add those exponents together. So 8 plus 6 gets us a to the 14r. Number 5, right off the bat, I see a 0 exponent. So remember, the 0 exponent applies to what's directly in front of it with that parentheses, so that becomes 1. So we really have negative 2 times 1, which is negative 2. So now we're left with negative 2 times the quantity, and we can multiply all of our exponents in that parenthesis with the x. So when we do that, we have a to the negative 2 times x, d to the negative 4 times x, over a to the 9 times x, and d to the negative 5x times x. So this 2, because we could write it as 2 over 1, is going to go into the numerator. So we have 2 a to the negative 2x, d to the negative 4x, all over a to the 9x, d to the negative 5x. So remember that we need to move our negative exponents. Negative 2, though, is just a number, so that gets to stay there. Meanwhile, the a needs to move to the denominator, the d needs to move to the denominator, and the d in the denominator needs to move to the numerator. So that leaves us with 2 d to the 5x over a to the 9x, a to the 2x, and d to the 4x. So our d's, because they're in different parts of the fraction, are going to subtract. 5 minus 4 gets us d to the x. And the a's are in the same part of the fraction, so we're going to add those together. So 9x plus 2x gets us 11x. And we still have that negative 2 in the numerator. Number 6, our last example. So we have a negative 2 exponent, so everything is going to multiply with a negative 2 exponent. So when we multiply everything with a negative 2 exponent, we get 3 to the negative 2, a to the negative 16x, c to the negative 2y, over 6 to the negative 2, a to the negative 2x, and c to the negative 18y. So notice everything in the numerator and denominator have negative exponents, so we are going to flip those from the numerator to the denominator, and everything flips this time because they all have negative exponents. So that gets us 6 squared, a to the 2x, c to the 18y, over 3 squared, a to the 16x, and c to the 2y. So I can square those numbers of 6 and 3 squared, so we get 36 over 9. Then a, the 16 is larger, so that's going to go on the bottom, so we have 16x minus 2x. C, the larger exponents in the numerator, so we have 18y minus 2y. Now, 36 over 4 can reduce, or 36 over 9 can reduce by 4, so we get 4 and 1 in the denominator. And then we have c to the 16y when we subtract, and a to the 14x. We don't need to put that 1 in the bottom from reducing because there's already a term in the denominator, and you don't always have to have a denominator, unlike when you have a number in it and not in the numerator.